Smith. Everyone I think here knows me. I work for the cloud platform team, and we help manage and operationalize a lot of the AWS environment. So today we're going to be talking through a lot of services that we actually use, have implemented, and that are realistic. That we like not things that are in the future, not making cool sounds, but things we actually use here. So I want to start out with a little bit of where we started in AWS. So we started with AWS, and we basically made this huge monolithic data center called DCND, or Data Center ND. So we have this one big account where all of our stuff is in it, and everyone's working together, and that led to some problems. So we had some early pain points with this design. It worked well if you were thinking about lifting and shifting and basically taking a one-to-one of what you have on-premise into the cloud, but we definitely ran into some early pain points. So one of those biggest early pain points we had was identity and access management. How do we give 40 to 50 people access to an environment with specific permissions on what they need to do? So this started with overly restrictive policies. So people were feeling like they were locked in a cage. I think Eric Schubert was probably one of the main ones. I don't know where Eric is, but he complained constantly that he couldn't do what he needed to do, and that he felt like restrictive, and every time he went to go do something, he couldn't do it. I think Melinda's one of those people as well. So then we kind of flipped it and said, okay, how can we make this a lot easier for everyone? So we switched to overly permissive policies. So when I leave my dog out for 12 hours, this is what he does in my house. He shreds everything. So what we've been trying to do, and we even have a project on the books for the last 6 months, is we're trying to find a balance of one extreme to the other, to be able to support everyone's initiatives and needs. And the things we're going to talk about in this presentation are going to help with that. So another early pain point we had was logging and auditing. How do we log in AWS? How do we log in the cloud? What do we log? How long do we keep these logs? And how long is it going to take us to go back and look through these logs if something happens? So that was an early issue. So we had lack of defined requirements, and we had a lack of consolidation. So all these logs were in disparate accounts. They weren't in one place, so it was easily manageable. So we also had inconsistent configurations and accounts. So this was a huge one and really annoying for people that are managing these, because there was no baselines for OIT accounts or our partner accounts, the linked account owners as well. So we'd go into these accounts and we'd check them out after they were built, and we'd want to configure them all similarly, but they're all different. That was a big issue. So even within OIT, our accounts were configured differently, which was a problem. Purchasing and managing reserved instances. This is a huge pain point, and even still is till this day. So with reserved instances, it's a way to save money in AWS. Brandon kind of mentioned this on day one last Friday. But basically, you purchase a plan for each specific instance type, specific family, and a specific operating system. You purchase this idea of reserved instance, and it gives you a discount on your overall bill for that specific instance. So we actually had to buy a special tool called Cloud Checker to just manage what instances we're getting which RIs applied to them. And then you have to start planning things like, how do I do my upgrade strategy if I can't change my instance families because we're locked into this thing for either a year or 3 years? How do we handle this? So this has been a big pain over time. So we're talking about new services that can fix this in a little bit. So another big pain point we've had was creating site-to-site VPNs. So after talking to networking, it sounds like it takes Bob Richmond around 3 to 5 hours to create a VPN, because he does it not very often, but when he does, he's the only one that can do it, and he doesn't remember exactly how he does it every time. So these VPNs that we're building to each one of these AWS accounts individually are painful. And the reason we would have a VPN is because we need to be able to have private connections from on-premise to AWS for each specific account, and we need internal resources to be able to reach out to the cloud as well without going through the public internet. And then finally, managing and scaling peering connections is a big problem. So as you start scaling out, you start needing accounts that need to talk to other accounts. And to do this today, you have to have an idea of a peering connection, peering two things together. That's fine and good when you only have 1 or 2 accounts that need to talk to each other. But when every account needs to talk to every other account in a mesh style system, it becomes an equation of n times n minus 1 divided by 2. So this is actually the same equation that comes into play with symmetrical encryption. So if you have 100 accounts that all need to talk to each other, I think this comes out to be around 4,950 different peering connections you have to have for this. So it gets a little out of control. So where are we now? Where are we now? We utilize native tools from AWS to ease governance, maintenance, and to improve security. I'll go into a little bit more detail what that means in a little bit. And we do have some custom integrations with tools like Surface Meow and FireEye.
Okay. You did
Um, What?
Did you say Surface Meow?
Yes, I did. So we're heading towards this idea of a multi-account strategy. So we're going to leave this monolithic account. We want to go to having multiple accounts for multiple different purposes. This helps us in a lot of different ways. So we can have easier IAM management permissions. So instead of having everyone that needs to do every single service, if we have an account, say for VDI, the only single services that are in there are VDI, so the only permissions you need are for VDI services. It's a natural permission boundary. What this means is if the account gets compromised, it's not a big deal because only your VDI stuff gets compromised, not the rest of your environment. So it doesn't affect Banner, it doesn't affect OnBase, it doesn't affect these big services because it was isolated and by itself. So limit the blast radius. It also makes auditing easier. So if I'm a security person and I'm looking at security logs and I notice that, oh, there's VDI type logs going on in the VDI account, I'm probably not going to care very much. But if I see someone starting to do certain crazy things like spinning up elemental and video stuff in the VDI account, that might be a problem that I need to look at. So it also makes billing a lot easier. So we've gone through a lot of iterations of GovCloud over time, but one of the biggest pain points in that environment is we have to try to track what person's using what instance and how much does that cost. Well, when you have a one-to-one with an account to a specific focal or chargeback, that makes it a lot easier because we know every single charge in that account is tied to that specific purpose and usage. So examples of this is the VDI account, like I already mentioned, and then a new account that we have called the Robot Process Animation Project. So this is all around basically a productive technology that automates human activities that are manual, rule-based, and repetitive. Jim gave me that, so it's his definition. But basically what it means is it's a fancy Selenium script, and we want to keep this segmented so we can do things like charge back to the controller's office or the pilot and stuff like that. So some of the tools we use that accomplish some of these goals. So AWS Organizations is one of the primary tools that we use. CloudFormation is a huge one. Savings Plan is a new tool that replaces RIs, and we'll talk about that in more detail. And AWS Transit Gateway. So there are some honorable mentions that we don't want to forget about. I'm not going to read off every single one of these, but they're all very important and do some cool stuff. So AWS Organizations. What is Organizations? Basically, it's a service in AWS that allows for the easier management of multiple AWS accounts, which is our major goal right now. So it does a lot of things that are really good for us. So central billing. So I talked about billing as a problem. Well, with AWS Organizations, it takes all of your AWS bills and brings those back up into a central account and makes the auditing or makes the reporting a lot easier. So we're able to do things like create custom APIs against the central account and actually iterate through each account and see what the costs are and do automated chargebacks. We're able to create new accounts through Organizations, which is really cool. Historically, I don't know how many people have created AWS accounts in here. I think, Tom, you said you made one recently. No, so like a personal account. Yes, so your personal account, you go in, you give them an email address, you give them a credit card, you sign up, and then you have to actually wait. So with Organizations, it's a single API call or button I press, and I give it an email address, and that's it. I don't need a credit card, I don't need anything. And it even works in GovCloud as well. So historically, after you put that credit card in to get a GovCloud account, you have to go make a special request. They do a background check on James Smith, which can take a while, and then you have to then wait, and then tie it back for billing. So you're able to create organizational units. So this is a ways to organize your accounts and to apply certain permissions to them. So if you think about, we have OIT accounts, non-OIT accounts, we have test versus production. So we have different rules around IAM permissions in these types of accounts. So we're actually able to apply these service control policies to these OUs to make certain things happen. And we'll go into more detail about that as well. So I can deny people from taking certain actions in test accounts while still being more, I can allow people to deny people in production accounts while allowing people to be more open and test their things. And then finally, you're able to turn certain services on at a global level. So this is across all of your accounts. So things like CloudTrail and AWS config. Yes.
So when you say create organizational units, test versus production accounts, you mean AWS accounts?
Yeah.
Okay,
So
in this
the way
scenario, my test stuff might be in one AWS account, my
Yeah.
cloud stuff might be in a different.
exactly, and you put those into OU. So at the root, you have all accounts, and then within there, you might have OIT and non-OIT, and then within OIT, you might have lab and then production, and you have different rule sets applying to each one of those depending on the type of account it is. And I'll go into more specifics around what those permissions are in a second. So this is what it looks like in a linked account to an organization when you turn on CloudTrail at the organization. Does anyone notice anything here? Turn on the logging piece.
Logging is on.
It's on, and what else is information? What else is interesting? Yeah, it's grayed out, right? So this means no matter what account you're in, so it becomes really nice because you no longer have to worry about that guard duty alert that enables you when CloudTrail is turned off, because it literally can't be turned off. Service control policies. There's some really cool things you can do around this that help when interns accidentally expose API keys to the world, so you don't have to go tracking down instances. So you can actually lock down whole regions of AWS. You can lock down instance sizes and families, so when the intern does expose the keys, they can only spin up tiny instances, and they can't charge you big dollars. You can lock down whole services. So if I have a production OU, and I know that Notre Dame just doesn't use these services, then I don't have to even enable them at all. I can just block them by default, plus more, right? So this is an example of what a policy looks like in organizations. If you're not familiar with reading JSON, it can be a little crazy at first, but essentially on the left, we're blocking instances larger than 2XL, and on the right, we're locking down anything that isn't US East 1 or 2, and that's Ohio or Virginia. So this would have came in really handy when an intern exposed API keys. So next I want to talk about is CloudFormation. So CloudFormation and organizations are really two of the big things we've implemented in the last year. CloudFormation allows us to build services in AWS as code. I have lots of examples of where I've used CloudFormation to spin up services. I'll go into it a little bit. So these allow us to use uniform configurations from predefined templates that we write, or sometimes Amazon just gives us. And these are known as CloudFormation stacks. And a CloudFormation stack can have multiple types of resources or the same resource. You can organize and spin it any way you want. Usually they're built using JSON or YAML files. I prefer YAML. Can anyone other than Jim tell me what YAML stands for? But yeah, Steve got it. You can have a sub for free. All right. So when you have CloudFormations defined, then you get to utilize some things called CloudFormation stack sets. And this is where it gets really cool and fun. So for me at least. So stack sets allow you to deploy stacks from a central AWS account. And remember we talked about the uniformity issue of different accounts are configured differently. Well, this kind of takes care of that issue. It's useful for common configurations across multiple accounts. So think single sign-on federation, your IDP, for instance, with like Okta. All of our accounts need to be federated with Okta. Everyone needs to be able to get into AWS, and they're probably going to go through Okta to do that. So we need to be able to quickly deploy an IDP configuration across all 100 of our accounts all at once. And this is a real scenario because we went to Okta last year and we had to configure this. So instead of logging into 100 different accounts individually and creating the IDP manually, we used CloudFormation stack sets to spin that IDP out across all of the accounts. I think it happened within a couple hours. It was the first time really using stack sets, so we didn't really try to hone in the performance on it. So we created our IDP and our roles in that fashion. So then any new accounts, we can quickly deploy the IDP and the roles out very easily. Other useful things for this is like security baselines. So in our stack sets in our primary account, we have something called Security Core. And Security Core is all of our core security services that we know we have to have for all of our AWS accounts. This is things like enabling guard duty, config. It used to be CloudTrail, but we turned that on with organizations. And then Security Hub is going to be one of the newer things we use. Also, we can set up CloudWatch rules, so we can send all of the events from all of our accounts to a central security account where they can create monitoring alerts from. And then finally, billing tools as well. So I can set up budget alarms for certain accounts based on parameters that they give us when we create the account. So if I have a professor that doesn't want to spend more than $100 a month, I can put a budgeting alarm in their account, and then they'll get an email whenever they hit that certain budget, and then they know they need to go turn things off. So it also allows for the agile deployment of new services. So a good example Amy brought up on Tuesday was Access Analyzer. So it was really painful to go do that because you have to manually go into every account, go to IAM, turn it on, and configure it. Well, this is where StackSets can come in handy. So how does it work? Magic. That's Jared's move. I stole it. So this is an example of using StackSets to deploy Access Analyzer. So on the right is the actual code for CloudFormation in YAML that actually builds out an Access Analyzer in an account. So all it is like 10 lines of code that says InfoSec owns this. This is an account. IAM Access Analyzer, and we're going to call it the InfoSec Security Core Analyzer. And then after I update one simple template in the production account, it gets rolled out to each other account that this is already applied to, and that change happens. So here I actually did this, and all these accounts on the left already have Access Analyzer enabled since Tuesday. So the next service I want to talk about is savings plans, because this was huge for my team specifically, so we no longer have to manage RIs. So it was released back in November, and it's kind of an alternative to reserved instances, because we got tired of managing them, and Amazon saw that people weren't taking advantage of those RIs in a good way, and it was too much for their customers to manage. So by committing to a certain level of spend, you get a discount. That's really all it is. And with Notre Dame, it makes it really easy because we've already committed to a certain level of spend over 5 years. So what we just had to figure out was how much of that spend do we want to use for EC2 specifically? And this applies to EC2 and Fargate. So if you combine Fargate with spot instances and savings plans, it's a massive discount for things running on Fargate. There's multiple types of commitments you can do with savings plans. You can commit to a 1 year or a 3 year, and there's paid upfront and no upfront. And depending on what you pick, there's different discount levels of those. The commitment is actually for an hourly spend. So you're saying I'm gonna run this many EC2 instances for this much value every hour. So if the on-demand price would be $20, you buy a $10 savings plan, and you'd only pay the $10. So that kind of gets a little crazy, but this is kind of what it breaks down to. So different instance types actually have different savings plan values. So if we take the example that John gave for Outpost, which is an M5 large, the on-demand rate is $1 almost, and the savings plan rate is 50 cents. So you could run two savings plan instances for one on-demand instance, and if you extrapolate that out, that becomes around 40 instances at the $10 an hour. So, or 20.
Before Frank, can you explain what spend on compute means?
Yeah, so every time you launch an instance, you're going to be paying for that instance, just like you're buying your Netflix subscription monthly. But this is hourly. So an M5 large instance, if you just go in the console and turn it on right now, that's $1 pretty much. But if you say, okay, yeah, 96 cents. And this is in Ohio. Sorry. Yeah, 10 cents, sorry. That's a half a cent. Anyways, pretend it's $1 an hour. It's definitely not. You can get some pretty graphics instances for that, but just pretend it's $1, okay? You're gonna be paying that. But if you say, okay, I wanna run this instance or multiple instances for the next year to 3 years, they're gonna give you a discount because they know that you're guaranteed to have that instance running, so they'll give you a deal.
AWS also just uses the word compute generically for anything that is executing. So it applies to all EC2 virtual machines, it applies to Lambda execution time, it applies to
Fargate?
things like Fargate.
It doesn't apply to RDS. I don't think it applies to Lambdas yet, but that's right. Yeah.
What does this do for the schedule? Does it eliminate the need for it?
No, it definitely doesn't eliminate the need for the scheduler, because our scheduler basically turns instances on at 7 a.m. and turns them off at 7 p.m., but you can still use that usage in other places. So if your instance isn't running, someone else might have an instance that is, and that discount just gets applied in that match.
I can give an example of major advantage here. So last year, James kept coming to me on the on-base side and saying, like, should I buy RIs for these servers? And it was like, well, I want to go from T2s to T3s. He's like, well, then I can't buy traditional RIs. I have to buy
Convertible.
convertibles, or they had something. So like we were constantly in like this, kind of like this, where are you gonna be in a year conversation, trying to save money on instances that we run 24/7. This completely eliminates that whole conversation, which some of us don't know with our apps and our load, what's gonna happen in 12 months. So then it's like, oh, we had 5 more instances, those could have been RIs if we knew they were. Or I need to upgrade these because something happened and now we lost that ability to use RI in that instance.
Yeah, and the other thing is we had been purchasing RIs in a single primary production account. We're kind of changing the strategy with savings plans, and I'll go into that in a little bit. There are 2 different types of savings plans: compute and instance, and they both have different benefits, right? So compute is like the easiest thing to do. It's the most flexible. You can apply this to any region. It doesn't matter where you are in your account. You can use any region. You can use any family and instance type, and you can use any operating system. So when it came to RIs, you had to pick a region, you had to pick an instance and family, and you had to pick an OS. So if you change that, your RI is not being used, that's money you just wasted. And we had a couple case scenarios where this was the case. Linux, you could change the within a family the instance size, but primarily you're kind of hosed. So unless you buy like a convertible RI, like Jim was talking about, where okay, I want to change my instance family, let me go ahead and do that. So the instance savings plan is a little more restrictive. It's more like an RI, so you have to pick a specific region and a specific family, and the rest is up to you. You can apply it across multiple OSs.
That's a bigger discount, right?
Allegedly, it's a bigger discount. It's up to, all of these savings plans are up to a certain percentage, which gets me to the next point. We did an analysis of savings plans and where would be the best to apply it here. And we came up with some interesting things because we wanted to look at, okay, what's best for cost savings, not just for like management, but cost savings. How do we save the most? And it turns out with the way we use these, the compute plan was the best. It didn't make a difference whether it was compute or instance. Compute was cheaper for us. And then we looked at time savings. So like our team has to sit there and manage, pay for a cloud checker, we can manage these RIs. And if we don't get it right, it ends up costing us more. So we buy RIs we don't need. So we look at time savings, cost savings. And finally, we looked at what's best for the university as a whole, and we decided to end up purchasing a savings plan based on usage for the whole payer account. So what that means is other accounts that have historically never had RIs, all of a sudden they're getting up to 60% discounts on their spend because we bought it at this payer account level. So it actually applies a discount across a very broad range of OIT services, but also other partners as well. So it's a service that OIT can provide to other people on campus. So we went ahead and purchased a 3-year no upfront savings plan. And that one was kind of interesting whether you do upfront or not upfront. They hit you with a 3% premium to not pay them in advance. But if we would have paid in advance with our enterprise discount, we'd have gotten hit by tax. Basically, you pay a fee, a percentage of that towards the enterprise discount or enterprise deal. So it would have cost us more to do upfront than it is not upfront.
You're all under non-disclosure
Yeah.
on the enterprise discount.
Yeah.
So anybody,
So we have enterprise support, and depending on how much you spend every month, the enterprise support costs more, like a tax bracket. So if we were to buy a 3-year upfront, we'd be spending like $400,000 all up front, and we would pay a tax on that. So then that tax like came out to around 7 to 10%, and to save 3%. So it made no sense to buy it upfront. So we ended up purchasing $15.90 of savings plans per hour, and we did some metrics this morning. Neither confirm nor deny, but it looks like we're going to save around $112,000 a year over on demand. So
How happy is it?
we're still looking through like how we track this, so it's up on the table.
Comparing on demand, what about compared to like what we just spent on RI?
That's what we're figuring out. How do you show those metrics? Because what we're looking at today is if you just look on a month-to-month spend basis, with an RI, it's kind of like putting a down payment on a vehicle, right? So you're paying $10,000 down and your payment's cheaper. With a no-front savings plan, you're paying as you go at that discounted rate. So if you don't amortize the RI spend over time, it looks cheaper than it would. So we're still trying to figure out what that looks like, because it's only been 13 days. Anything to add, John? Like I know.
No, I'm not touching.
so I put in my goals and coaching plan less than half of that. So I'd like to know how.
Nice.
So we exceed my.
Under promise and overachieve.
I think I talked with JC, said 3,000 a month.
So we're doing pretty good. And some of that depends on where you buy it, and the initial estimates may have been around purchasing it in one place versus the other. So the next topic is AWS Transit Gateway. So we talked about those VPN connections, the peering connections, how it's really annoying to manage. Well, the savior of Transit Gateway is here. It is the router in the cloud. So what that means is it's scalable. It supports thousands of VPCs in any account, and now I believe today any region. So you can peer regions across accounts and anywhere you want in VPCs. And you only need one pair of on-site VPN tunnels that are dual homed, and you can get up to 4 gigabits per second throughput. And then you have redundancy as well as speed. And I no longer have to have VPNs in every single account. So it sounds awesome. And it's much easier to manage. In fact, the networking team at one point told me, don't script this because you're going to put us out of a job. But now they said, here, you manage everything in AWS, and we'll manage the link to it. And that's kind of where we're at. So think multi-account strategy. So,
I mean,
it doesn't need to be explained. It's from an Adam Sandler movie called Anger Management. I don't know. So this is what it looks like today. We have the dome, and I don't think the ASRs are in the dome. They're not, but let's pretend they are. So we have VPN tunnels through every single account that need to connect back to campus. We also have these lines between accounts for accounts that need to talk to each other. Those are pairing connections. And almost every account has a tie back to shared services. Shared services are things like DNS, Active Directory for authentication, some security tools, and then monitoring. So all those things have to be paired together, linked together, which is a big pain because you have to manage each one of those, and there's account limits on the VPC pairing connections you can have. So Transit Gateway is the future. So in the Transit Gateway model, it becomes more of a hub and spoke, where you have the central router account where the Transit Gateway sits, and it can route traffic to wherever it's destined based on route table entries. So in this scenario, every account is tied back to the Transit Gateway through a Transit Gateway attachment, and they each have route tables in each one of these that say, go here for anything to campus. And then on the central route table, central Transit Gateway account, there's a route to each other account and to campus. So it'll know, okay, you go here, you go here. So that's kind of what the design looks like now, like once we get finished. So we currently have a Transit Gateway, and it is in place, and we have around 4 accounts connected through it. These accounts are the robot account, the VDI account, our CPS account for our own testing, and then VPC in the Transit Gateway account that we can use for testing the tunnel, whether it's up and down. So you don't actually need a VPC in the Transit Gateway account, but we want it to be there for networking and be able to test that tunnel, since that's where we draw the line, and that's where they manage. So we're working on setting it up with shared services. I actually was trying to do it yesterday morning. We found some routing issues on the ASRs, and we're going to get that fixed. So we're going to move that until next week or the week after. This will allow all new accounts to access DNS and Active Directory through the Transit Gateway, so we don't have to peer each one of those anymore. And then we'll start working on the strategy to migrate old accounts. So any questions around Transit Gateway? I know it's I kept it really high level.
did you notice any performance differences?
No one's noticed any performance issues. It should actually be as good, if not better.
And then we only need like the 2 ASRs on campus for the foreseeable future. That's just our standard way to get to the Transit Gateway. And then,
Yeah, absolutely. Unless we did like a direct connect or something like that. So Transit Gateway supports either a direct connect or site-to-site VPN to it as well. Yeah. So we have, I think, 60 or 70 active accounts. Not all of them need the tunnel. Not all of them need to talk to shared services. But what we're preparing for is that multi-account strategy. So we do have some accounts that are peered just to consolidated applications, some that are peered just to shared services. But like the robot account is actually peered to shared services and is peered to CA. So once we actually transition to shared services, we can get rid of that peering connection and route it through the Transit Gateway. So do you have a question?
Can you go over some of the cost differences between, like what's the cost for Transit Gateway versus what we use?
Yeah, for sure. So we did a little bit of cost analysis in the beginning. So essentially, you actually pay for the traffic between the accounts and the Transit Gateway. But what you save money at is the VPN connections, because you don't need those anymore. I believe that's around $50 a month per account that has these VPN connections. So it depends on the amount of traffic you have. So if if you're not doing a lot of account-to-account traffic and all you're paying for is the access to the tunnel, it's going to be a lot cheaper than that $50. Where you start getting into connections between consolidated apps and shared services, where you're moving lots of data around, like say through consolidated apps back to campus for EMFT jobs, then you might want to consider leaving the VPN tunnel up because it's cheaper than the throughput you would pay through the transit gateway. If that makes sense. So some analysis needs to be done.
Is that part of what you're going to monitor then, is look for like really high transit gateway counts?
Yeah, for sure.
But you also might take 2 accounts and merge them, those traffic.
I think we probably keep the multi-account strategy based on security and like management ease rather than cost of transit gateways. Then you might peer them for
So
some.
you say you can still peer, what's the limit on peering?
You can, soft limit is 50. After 50 accounts that are peered to a single one, you start getting potential for performance degradation. Yeah, so it depends. So we are at like 30 or 40 for shared services right now. So we're at that limit of like, okay, we need a solution and transit gateway is available. So let's just move towards
So each account had 50 peering.
each VPC. So yeah, peering is all between VPCs. So. So some of the next steps that we want to start taking a look at for this management piece is AWS Control Tower. It doesn't currently support existing organizations. We're waiting until it does. There's a beta out right now. After initial review with InfoSec and our technical account manager, Control Tower doesn't seem to do a lot of the things we'd want it to do, and it would pigeonhole us into certain areas. So it automatically enables Amazon SSO, which we don't really need because we have IDP already. We have Okta, and then there's some other things it does that you don't really need. So we also want to look at EC2 Image Builder for sharing images across multiple accounts. Because as we start getting multiple accounts out there, we might want to have a standard image for everything in AWS and be able to share that out. Yeah.
What is that versus just sharing AMIs?
You can share MIs, but Image Builder will like build on top of things. So it curates like a pipeline. So you might start with the base Windows 2019 image, and then you install software on it through a pipeline, and then you share those out with accounts in that method. You can also use Ansible and the share AMI. There's a lot of things, or Jenkins can do a lot. And finally, I want to look at the AWS Service Catalog for offering services to linked account owners as well. So I can create a CloudFormation template, apply it to Service Catalog, and say, okay, here's our base template for S3 buckets. Anyone that needs a bucket in an account, just go click this button, and then a bucket gets created. Or if we have accounts that we know, like the library could utilize our scheduler, we could then potentially share out with them a scheduler role that they can apply to their account, and then just put tags on their EC2 instances and start utilizing our scheduler. So it would save money for us and them. So it's kind of a benefit. Cool. So any questions?
Back to savings plan. So you said it's per hour. It's like committing to an hourly spend, 15 something an hour. So a popular schedule tag is 7 a.m. to 7 p.m. So does that mean if you had, let's say hypothetically had an account going to savings plan on that only had 7 to 7 schedules, that would then commit to 12 hours of what you're
You
spending?
can't. It's all hourly for 3 years. So there's, in that case, you have a peak and a valley of usage. So there's 12 hours that you're getting awesome savings plan deals, and there's 12 hours you're throwing away savings plans.
So does it average out though?
Yeah, so well, it depends on if you start sharing with multiple accounts and other people have higher peaks in different areas. You can, yeah.
I guess like Christina, like that scenario where you had 12 hours of dead time, they average it out and say like, well, instead of $2 for every hour, it's $1.
I don't think so. Jason's right there with.
So
No.
Jason's helped us with the, so we did a graph, like usage, and on the weekends, it drops down. And what you want to make sure is that the amount we're covering with savings plans isn't just going to be wasted in our hours of low
So
usage.
we're really committing to 24/7 spend. Like our 24/7, that's what we identified.
And then, like we said, if you look at our usage, there's a base usage across the board, and there's peaks and valleys depending on whether you're turning things off. So what you want to buy for it is like making sure that you're not falling into those dips very much. You want to make sure you cover that. And then there's other strategies people can do. Like you can still buy RIs. You can still use spot, and they cover it.
And what we're going to do is kind of keep an eye as RIs come due, to convert from using an RI to a savings plan, and then monitor see, did that do what we thought it was gonna do? And we can, over the year, we're expected to be probably off of all RIs, right?
Yeah, I think that's the plan as of
Oh.
now. And then one last thing with around savings plans, as you start optimizing EC2 instances, so you can downsize them, then you get more for your money because your savings plan covers more. Because I mentioned like an M5 uses X amount of 4 cents an hour, it uses 4 cents. So if you scale it down to the medium, it might be 2 cents. So then your money goes farther. Something to keep in mind.